Most people think a new house means fewer problems, better materials, and a longer lifespan. But in a lot of cases, that is not what buyers are actually getting. Behind the fresh paint, open floor plans, and polished model home finishes, many modern homes are built with materials chosen first for speed, scale, and cost control. That is where the builder-grade trap begins. The real issue is not that these homes break the rules. The issue is that they are often built to meet the minimum standard, not to deliver maximum durability. And once water, time, and wear start doing their job, that difference becomes impossible to ignore. What makes this even more interesting is that some buyers are quietly avoiding that trap altogether. They are looking at older homes, reclaimed structural wood, local lumber, and alternative building paths that give them something modern production housing often does not: real substance. In this video, we are going to break down how the market shifted toward lighter, faster, more disposable materials, why so many people feel disappointed after paying premium prices for builder-grade construction, and what some smart Americans are doing instead. Because the so-called 500-year loophole is not really about nostalgia. It is about understanding which materials last, which systems fail first, and how informed buyers are learning to spot the difference before they sign the papers. Number 1. The real trade-off. When people say builder grade, they are usually not talking about a house that breaks code. They are talking about a house that was optimized to meet code, hit a target price, and go up fast. That distinction matters because building codes are minimum safety rules, not a promise of maximum service life, best materials, or easiest maintenance. So, the real issue is not that every house built after 2000 is bad.
The issue is that a lot of production housing is designed around speed, standardization, and cost control first, and long-term durability second. Once you see that, the word scam starts making more sense. Not as a legal claim, but as a buyer's feeling after paying premium money for a house assembled from baseline materials with very little margin for neglect, leaks, or cheap substitutions. In other words, a builder-grade house can look brand new and still be full of short-cycle decisions. Thin trim, basic windows, commodity framing, minimal overhangs, cheaper plumbing fittings, and panel products that perform fine when kept dry, but age fast when water gets in. That is the frame for this whole story. The smartest buyers are not assuming new means durable. They are asking a simpler question. What exactly am I paying for? And how much of it was chosen because it lasts versus because it installs fast and pencils out for the developer? Number 2. What changed? A big part of the answer is that American wood construction became standardized, industrialized, and highly optimized for volume. Before industrial wood production took over, lumber was milled more locally, sizes varied, and builders were often working with rougher, heavier stock made for the job in front of them. Over time, standard sizes and grading systems made national distribution easier, which solved real problems in trade and code enforcement. But it also pushed housing toward a commodity model. The famous 2x4 tells the story. What people still call a 2x4 is now typically an actual 1.5 by 3.5, and that shrinkage was not one sudden switch. It was a long process tied to drying, surfacing, standardization, transportation, and material efficiency. So when buyers open a wall in an older house and find studs that feel chunkier and heavier,
They are not imagining it.
In many older structures, the framing really is closer to full size, or at least rougher and more substantial than the dressed material people expect today. That does not automatically make every old house stronger, but it does explain why old framing often feels like a different category of product. The market moved from made-for-place lumber toward interchangeable commodity lumber, and that shift changed not just size, but also how people think about what a house is supposed to be: a long-life structure or a fast repeat product. Number 3. Why old wood feels different. The next piece is wood quality, and here the cleanest way to say it is this: mature wood and juvenile wood are not the same thing. A huge share of modern timber supply comes from managed plantations and improved trees grown for yield, speed, and predictable output. That system is efficient, but wood science has been pointing out for years that higher juvenile wood content generally means lower density, lower stiffness, and weaker performance in some structural properties. Forest Products laboratory work on southern pines found that as juvenile wood content rises, density drops, and one study reported the 100% juvenile material was about 15% lower in density than the 0% juvenile material. Other research notes juvenile wood in southern pine is typically around 10 to 15% lower in density than mature wood, and reductions in density are tied to reductions in stiffness and strength. That does not mean every board at the lumberyard is weak. It means modern framing lumber is engineered around acceptable averages and grading systems, not around the old expectation that every piece should feel dense, resin-rich, and overbuilt. This is why reclaimed lumber and old framing often surprise people. They are noticing a difference that wood science already describes. Older boards often come from trees with more mature wood, tighter growth, and less juvenile core relative to the usable section. So the gap is real, but it is better explained by forestry and material science than by nostalgia. The wood did not become fake. The supply system changed, and the properties changed with it. Number 4. The chestnut lesson. American chestnut is the clearest symbol of what older builders had access to and why people still talk about it with almost mythical respect. In the East, chestnut was once one of the defining trees of the forest, with some estimates putting it at roughly 1 in 4 hardwoods in parts of its range. Its wood was straight-grained, commercially valuable, and famously resistant to decay, largely because the heartwood carried tannins and other extractives that made it naturally durable. That is why chestnut showed up in framing, posts, poles, ties, and countless rural buildings that stayed useful for decades. Then, chestnut blight wiped out the species as a dominant timber tree, and that was not just an ecological loss, it was a material loss. Builders lost access to a naturally durable domestic wood that had real advantages in service. The important point, though, is not to turn chestnut into a fairy tale. Not every old house was framed in chestnut. Not every old board is magic. The real lesson is broader. Older American construction drew much more often from mature, heartwood-rich material and from species whose natural durability was taken seriously. Modern buyers have been trained to think durability comes from coatings, pressure treatment, and replacement cycles. Older builders often started with species selection itself. That mindset is part of the so-called 500-year loophole. The loophole is remembering that durability can begin with the wood, not just with the chemical treatment or the warranty card. Number 5. The panel problem. This is where a lot of people go too far and get sloppy, because OSB is not junk in every situation. It is a code-recognized structural panel, And when it is used correctly, detailed correctly, and kept within its moisture limits, it does what it is supposed to do. The problem is that people often treat its code approval as proof that it is equally forgiving under abuse, and that is not the same thing. APA guidance and manufacturer documents are clear that common rated sheathing with an Exposure 1 bond classification is intended for temporary exposure during construction, not long-term wetting.
They also spell out the trade-off. Moisture exposure can cause edge swell, surface flaking, mold, and mildew. And APA technical notes note that thickness swell in OSB is generally greater than in wood because of compaction stresses from pressing. So the issue is not that a modern house uses panels. The issue is that a modern house often depends on thin members and sheet goods that need much tighter moisture discipline than older, heavy stock. The assembly may be strong on paper and perfectly legal, but it can still be a lot less forgiving once the real world shows up. When the drainage plane is poor, a window is flashed badly, or a plumbing leak sits hidden in a wall, the assembly can lose its margin very quickly. That is why a lot of buyers feel cheated. They were sold a high sticker price, but much of the shell is made from products that perform best only when the details are perfect. In the real world, details are not always perfect, and that is where the trouble starts. And it adds up fast. Number 6. Water decides everything. And once you understand that, the argument becomes less emotional and more practical. Houses usually do not fail because the wood suddenly forgot how to be wood. They fail because water keeps getting where it should not go, and the assembly cannot dry. Research on durability in wood buildings keeps coming back to the same point. Moisture drives decay, mold, and dimensional problems, while good detailing that blocks bulk water and promotes drying dramatically changes service life. One long-running durability review put it bluntly by saying, "Weather-exposed wooden structures usually fail from decay, not from pure structural mistakes." That means the real builder-grade trap is not any single material by itself. It is the pairing of low-reserve materials with weak water management. Minimal roof overhangs, bad kick-out flashing, cheap window installs, deck ledgers that trap water, low-clearance siding, wet basements, and poorly vented bathrooms all create the same story in slow motion. The smartest buyers know that a house with ordinary materials and excellent water detailing can outperform a house with nicer finishes and bad moisture control. They also know old wood is not immune. If an old sill or joist stays wet long enough, it can rot too. So the most useful mindset is not old versus new. It is forgiving versus unforgiving. Dense lumber, naturally durable heartwood, and heavier sections often give you more time. Good detailing gives you fewer problems to begin with. Put those together, and now you are talking about a structure people can keep instead of constantly chase. Number 7. Fire changes the math. Fire is another place where the difference between big wood and light wood becomes obvious. Thick timber does not become fireproof, but it behaves in a way engineers can model. As exposed timber chars, the char layer acts as insulation and slows heat moving deeper into the member, which is why code methods for mass timber and heavy sawn members are based on calculable char depth and effective section loss. That is a very different behavior from lightweight floor systems with thin webs and less reserve material. Fire service and research groups have warned for years that unprotected engineered I-joist floor assemblies can fail sooner in fire than older solid sawn floor systems, which is why collapse recognition and fire protective details matter so much. That does not mean every I-joist is unsafe,
because code-compliant assemblies can include protective membranes or tested equivalency paths. It does mean buyers should stop pretending all wood systems age and fail the same way. A heavy timber beam gives you mass, charring behavior, and a core that can hold on longer. A lightweight member gives you efficiency, long spans, and less material, but also less forgiveness when conditions get ugly. That is the deeper pattern running through modern builder-grade construction. The industry has become extremely good at hitting acceptable performance with less material. The buyer's problem starts when acceptable performance gets confused with robust performance. Those are not the same thing, especially in a house you hope to own for a very long time. Number 8. The paperwork loophole. Now we get to the part people usually miss. The escape hatch is not illegal, and it is not some hidden clause nobody wants you to know about. It is mostly a code and documentation issue. Under modern code practice, structural lumber is generally expected to carry a grade mark from an approved grading agency, because inspectors need a standardized way to know what the piece is supposed to do. But that is not the whole story.
Code commentary explains that a certificate of inspection can be accepted in place of a grade mark for pre-cut, remanufactured, or rough-sawn lumber, and for larger sizes, and residential code language also allows alternative materials and methods when the building official is satisfied they meet the intent of the code. On top of that, some states run native or local lumber programs that train and certify small mill operators or graders, so locally sawn material can be used for structural applications under defined conditions. Tennessee's Native Species Lumber Act is one example. Alaska now has a local lumber grading path aimed specifically at letting locally produced lumber substitute for grade-stamped lumber in certain residential uses. So the real loophole is not beating the code. It is using the code properly. Rough-sawn local wood, reclaimed beams, and salvaged heavy timbers are not automatically banned. They just need a recognized path. Grading, inspection, engineering, or local program approval. That is why smart buyers talk to the engineer and the building official early instead of arguing on the internet late. Number 9. Buying the bones. This is why some of the smartest buyers in the country are perfectly happy to look at an ugly kitchen, dated wallpaper, or a rough exterior if the frame underneath is honest. They are not shopping the finishes first. They are shopping the bones. In older homes, especially those built before post-war standardization fully took over, you can still find rougher, heavier framing that is closer to full size than what most people expect in a modern tract house. That does not mean you buy every old place you see. It means you know what to inspect. Foundation movement, roof leaks, bulk water entry, basement moisture, insect damage, and amateur alterations matter more than whether the bathroom tile looks old. And when the house is from the pre-1978 period, you also have to treat lead paint like a real issue instead of a footnote. EPA and CDC both warn that homes built before 1978 are likely to contain some lead-based paint, and the risk rises when paint is deteriorating or disturbed during renovation. Federal disclosure rules also require known lead information to be shared before sale, which means buyers have no excuse to treat that issue like background noise. So buying the bones is not romantic. It is selective. Keep the dense framing if it is sound. Upgrade the mechanical systems. Correct the drainage. Remove bad past repairs. Handle lead safely. The win is that you may end up with a house whose core structure came from a slower, heavier material era, while the parts that truly benefit from modern technology, like wiring,
membranes, and climate control get brought up to current standards. That is a much smarter trade than paying extra for all new finishes wrapped around an average shell. Number 10. Building new without playing cheap. The same logic applies if you are building from scratch. The smartest move is not automatically to reject every modern product.
It is to stop letting the whole project default to the most commodity version of each decision. There are legal, code-recognized ways to build with more substance. Post and beam, timber frame, heavy sawn members, glulam, and mass timber all give buyers paths toward a structure that is not just a thin stud and panel box. And the code is not hostile to that idea. The 2021 International Building Code added new tall mass timber construction types and explicitly allows mass timber buildings up to 18 stories in some occupancies, which tells you something important. Big wood is not a nostalgia hobby. It is a modern structural system with a code path. At the house scale, locally milled or rough-sawn lumber can also be viable when the project uses a legitimate path such as certified grading, a certificate of inspection, or engineer approval, depending on the jurisdiction. The key is to be honest about what still needs engineering. A timber frame still needs a proper lateral system. A custom build still needs detailing for water, fire separation, and connections. But that is exactly the point. Smart buyers are not trying to go backwards. They are trying to spend money on structural decisions that keep paying back after the paint color and cabinet hardware stop feeling new. Once you think that way, builder grade stops being the default and starts being one option among several, usually the shortest life one. Number 11. Reclaimed is not just aesthetic. A lot of people still hear reclaimed wood and think it is only for restaurant walls, floating shelves, or expensive design flexes. That is missing the more serious use case. Reclaimed framing lumber and large salvaged timbers can be structural resources when they are assessed correctly, and they also carry a real environmental upside. Forest Service research found reclaimed framing lumber and wood flooring have significantly lower environmental impact than comparable virgin alternatives. Other Forest Service work on lumber from building removal points out that the timber framing world has long relied on job-specific grading and engineering approval to bring salvaged timbers back into structural use. There is even research from deconstructed houses in Florida showing salvaged lumber averaged about 50% greater density than virgin lumber tested under the same conditions, though that kind of result should be treated as case-specific, not as a promise for every salvage pile you see online. That is why smart buyers do not confuse reclaimed with random. They want provenance, species ID, moisture readings, denailing, grading, and engineer sign-off where needed. Done right, reclaimed wood is not a style move. It is a way to buy back mature material qualities that are harder to get in brand-new commodity lumber, while also skipping the environmental cost of making the same framing material twice. In a market full of products designed for replacement, reclaimed structural wood is one of the few categories that can honestly improve with age, as long as the piece stayed dry and someone competent verifies what it can still do. Number 12. What to ask before you pay. So, the practical move is to stop being impressed by whatever is easiest to photograph and start asking questions that expose the real structure. Ask what kind of floor system is carrying the main spans. Ask whether the roof has enough overhang to help the walls stay dry. And ask what protects the sill and lower wall, where houses often start to tell the truth. Ask what panel product is in the walls and subfloor,
and whether the design gives that panel a drying path if water gets in. Ask how windows, decks, and roof wall intersections are flashed. Ask whether treated lumber is paired with the right hardware, because residential CCA treatment was pushed out of most uses after 2003, and the copper-based replacements such as ACQ and copper azole can be more corrosive to fasteners than older CCA formulations. Ask whether a local sawmill package can be certified, inspected, or engineered instead of assuming the big box stud pack is your only legal option. If you're looking at an old house, ask for the water story, not just the renovation story, and get LEED disclosures seriously on any pre-1978 property. If you are looking at a new house, ask for the material schedule and the exact assembly details instead of the sales brochure version. These questions are not flashy, but they cut straight through the builder-grade trap because they force the conversation back to service life, moisture tolerance, repairability, and code path. That is where the real value lives, not in whether the house was built last month or in 1938, but in whether the structure was assembled like something you keep or like something you keep fixing. Read the specs, not the staging.